Good afternoon and welcome. Welcome to 14F, session 14F. I'm Derek Strauss and I have the pleasure of having Nick, Bill, and Mo with me. And I'll introduce them a little bit later, but just first the title. The title of this session is Using a Data Mesh Architecture to Build a Sustainable Knowledge Graph for a Mega Construction Project. Okay, I think that sets the scene really nicely. And we're looking forward to hearing from this team of gentlemen that have been focused on doing that. So a real practical session, looking forward to hearing what they have to say. I think I'd like to just go ahead and firstly, just mention to the audience that there are polling questions related to this session. And so if you go into the Hoover app and you hop on there and look for the polls around session 14, you'll see there are 3 polls. The first one is, how important is sustainability to your organization's mission and goals? The second is, how mature is your organization's sustainability reporting? And the third is, how mature is your organization's sustainability data platform? All 3 really important questions. And of course, the more of you that respond, the better the picture is going to be that we'll be able to share with you a little bit later on. So please do go ahead and hop onto the polls and answer accordingly whilst the session's going. All right, with that, I would like to now hand over to Nick. Nick's going to lead off and he'll be handing over to Bill and to Mo at the appropriate times. So away we go, Nick.
Great. Thank you very much, Derek, and welcome everyone. It's certainly a pleasure to be a part of the CDOIQ community and the event. This afternoon, I would like to walk you through the use of graph and data mesh technologies to help model environmental impact. To do this, we'll be covering a major construction project, as Derek mentioned, where these technologies have been applied. RD Digital is a specialized consulting company that is deeply committed to working in partnership with our clients and global communities to drive value through transformation of enterprise sustainability, with net zero, as we know, is everyone's goal, and certainly is ours. We offer comprehensive sustainability platform and complementary services that will significantly reduce both the time and cost required to achieve what now are becoming aggressive global decarbonization targets across all sectors. Slide, please. Thank you. As Derek mentioned, my name is Nick. It's Nick Revelas. I'm the Chief Revenue Officer of RD Digital. And with me supporting is Bill Puglia, RD's Chief Product Officer, and Mohammed Zakaria, our Lead Sustainability Consultant. What we're trying to do with RD is to help companies accelerate the journey and to meet and ideally exceed climate and overall sustainability goals. The way we're doing this is by linking millions and millions of data sets together, which would otherwise be really time consuming and complex to do without the use of advanced graph technology. What graph technology also allows you to do is to build those complex relationships between the nodes and allows you to store and query them. It also allows you to determine from those relationships what's likely to happen next. Underpinning technologies is the principal architecture of using a data mesh consisting of data products, which are essentially groups of domain-specific data assets which should be owned by a business. It's very API-driven and then interactive with using graph technology and deep visualization. Slide. So now let's look at the sustainability journey for a typical engineering, procurement, and construction company, or in the industry referred to as an EPC. The slide highlights the traditional life cycle or value chain, with project elements on the left, which are typically referred to as greenfield, and operational to decommissioning, which is on the right, and that's referred to as brownfield. There's a major shift in the global construction industry to approach projects looking at the life cycle, taking into account critical elements of a circular carbon economy and not doing so in the typical silos. If you're not aware, the construction industry is the third largest producer of carbon emissions in the world. And the reason for that is they are obviously heavy users of steel, cement, and glass. All three are major carbon contributors because of their vast consumption of energy. So if we look at the typical process of design, you might get the investment firm, then you have design concepts, followed by detailed design, and then you actually move into the build phase. Post-build is operations, maintenance, modernizations or upgrades along the way, and then essentially decommissioning or end of life. There are two different halves of the process that really need to be modeled. The first half, the design phase, obviously before anything has been built, allows us to work with our clients to look at this project in more detail, not just the financing, the architectural options, but working with them to decide where the most sustainable options are, the processes involved, and the materials that will help reduce the carbon and environmental impact. We've shown that 60% of carbon can be reduced in multiple ways in this phase. Firstly, by using alternatives to, say, concrete, the volumes of, the impact to supply chain, and a variety of energy sources required. All these can result in the reduction of carbon emissions and environmental impact. The ARTI Sustain 360 platform allows our clients to achieve this. Once we are in the build and maintain and operate phase, there's a lot of environmental costs in the construction and transportation to actually pull the project together and hand over and commission. Then the maintain is really centered around the building, the facilities management, such as heating, ventilation, air conditioning systems, and lighting. And in this phase, the improvements of operational efficiency, delivering emissions reductions of anywhere between 15 to 25%, so 60 in greenfield and up to 25% in operations. This coming all together in the construction industry, ARTI is focusing predominantly on the design in the short term, but life cycle implies that it is the entire journey of an asset or a product, and we will naturally extend those capabilities. So now let's look at a real example. This is a live project for ARTI, who is working in close collaboration with other partners. This giga project, currently the largest in the world, is called The Line, which is a linear smart city under construction in the Kingdom of Saudi Arabia. Its planned community is referred to as NEOM. It is designed to have no cars, streets, or any carbon emissions. This 110-mile city is part of the Saudi Arabia Vision 2030 project. The specifics of the project were to model the construction of a major tunnel with 6 rail tracks being built underground, spanning over 100 miles, connecting one end of the country to the coast to the other end. The tunnel is built in 3 segments. Firstly, an express high-speed line, like a bullet train going from the start of the tunnel to the end of the destination. Secondly, a service line, which will operate cargo trains, providing goods and services along the way. Thirdly, passenger transport, like a metro type line that stops at various stations as well. These tunnels are obviously being designed by architects and engineers, and our task in collaboration was presented to us as an innovation challenge. Some of the items. So how do we, 1, accelerate the speed of construction? 2, reduce material demand, especially concrete, and the environmental impact of concrete. How do we optimize the life cycle and sustainability of the entire project? How do we reduce the cost and total cost of ownership? How do we maximize the prefabrication to minimize on-site manual labor to ensure as much as possible its pre-assembly is brought to the site? Difficult in that region logistically, and that's a major factor for the kingdom and for the constructor and the owner. And finally, the biggest is minimizing the carbon footprint and overall emissions. These were aggressive goals, which were identified by the project team and the owner, So Artie had to work with the client in partnership to come up with the options to meet these objectives, which we did. And it's worth noting that if this project were to continue in a normal design fashion, it would be one of the biggest contributors to carbon production in the world. So some of the design options that were considered and modeled. Artie and our partners leveraged value-based design engineering, and we created sustainability as the first port of call in early design. And we modeled those 3 different tunnels in construction. The client provided us with a baseline design for the tunnels. This was a simple box arrangement with base, walls, and roof, all made from concrete using traditional cut and cover tunnel process. Artie used the Sustain 360 platform to analyze this baseline and establish the carbon emissions for this default design. We had to baseline the baseline, essentially. Our engineering architect partner then looked at the 3 alternative design concepts that would meet the key objectives. The alternatives were looked at from a design perspective in terms of shape, the boring of these tunnels into the ground, and then also from materials perspective to look at alternative materials which could replace concrete, which we know is highly delinquent material in terms of overall carbon emissions. In this case, the alternative material selected by the engineering firm was glass fiber reinforced polymer, which potentially would have a significant reduction in carbon. There were multiple variables here in terms of production methods and material options to reduce the carbon. I'll now hand over to my counterpart, Bill. Bill?
Thank you, Nick. So you can go to the next slide, Derek. So I'm going to take you through a little bit of the framework, the approach for life cycle assessment, and an overview of the software before we get into a demo and a Q&A. So the methodology that Artie uses to conduct these types of assessments is based on a circularity framework, which is tied to an ISO standard 14040. This framework allows you to look at an end-to-end or cradle-to-grave view of the product or a project with the aim of eliminating waste and extending the life of natural resources to minimize the impact on the environment. And as you can see in the graphic, the first phase would be looking at it from a material perspective. Then the packaging and inbound transport to the plant, the product production, the transport to site, the actual construction build phase, and then the use of the building all the way through end of life. Circularity allows for all stakeholder needs across the life cycle to be addressed holistically rather than in isolated data silos. For greenfield projects, these consider phases 1 to 5 of the life cycle and involve design architects and general contractors and EPC firms for construction, as Nick explained on an earlier slide. Then there's a handover to the asset owner or the operator for phases 6 and 7. In most cases today, end of life is often not considered. And as you will see when we show you the case study later on, the carbon impact of end of life can be quite substantial. Within each of these 7 phases, there are environmental metrics that need to be measured. This slide references some of them. There's 13 in all that we consider. The one that we're all familiar with is carbon footprint in terms of CO2 emissions, but there's also eutrophication, human toxicity, energy, waste, etc. One of the things that makes Artie unique is the use of an environmental cost indicator, which converts all of those metrics into a single normalized financial value, which reflects the societal cost of the project. So it kind of enables you to look at like triple bottom line impacts. This provides an additional dimension to the analysis when comparing options, either at a finished product level or at a component material level. And in this case, we're looking at the ability to compare concrete with glass fiber reinforced polymer, or GFRP. You can go to the next slide, Derek. So this slide provides an overview of the standards and methodology for life cycle assessment. The aim of the project was to conduct a life cycle assessment from cradle to grave for the design options that Nick reviewed with you, using ARDI's knowledge graph software, using multiple external databases, environmental product data sheets, which contain all of the details around the materials used, and supplier information. On the right-hand side, you can see that we group our process into stages, production, construction, operations, etc. And these align with scope 1, 2, and 3 classifications per the greenhouse gas protocol, or the GHG protocol. Each contributor to carbon emissions is then classified into the appropriate scope. So for those of you who are not familiar with GHG or scope 1, 2, and 3, when you're looking across the life cycle, scope 1 relates to direct emissions from sources owned or controlled by the reporting company. So this could be, CO2 emissions from the combustion of fossil fuels for electricity or transport. It could include nitrous oxide generated from industrial processes like cement production. So scope 1, direct. Scope 2 is indirect emissions from the generation of purchased electricity, heat, or steam needed to support the production. So this could include CO2 from the generation of purchased electricity, whether you're purchasing it from a renewable source or from the burning of fossil fuels, et cetera. Those are going to have an impact on your carbon footprint and an impact on your scope 2 emissions. Scope 2 could also include indirect emissions from methane and nitrous oxide generated from the purchased heat or steam. Scope 3 is other indirect emissions that could occur anywhere during that value chain. That could include CO2 generated from the transportation of goods and services and finished products. It could include CH4 from the disposal of waste. It could include nitrous oxide from the use of fertilizers. So all of this is considered as part of that circularity framework and the end-to-end life cycle in order to understand the complete life cycle view of your carbon footprint. The ARDI sustainability platform has scope 1, 2, and 3 already modeled in their data products, which is a real game changer. So scope 1, 2, and 3 emissions classification is performed automatically, and it aligns to the internationally recognized standards shown on the left-hand side of the slide. So for example, if we recognize something as an energy source, it will automatically be considered as part of this, as part of scope 2. And on the next slide, I'll provide an overview of the ARDI sustainability platform and how some of this works. So you can go to the next slide, Derek. So a core foundation of the ARDI Sustain 360 solution is a sustainability data lake and a platform that's built using knowledge graphs with embedded analytics that calculate environmental metrics and advanced AI capability to enable net zero optimization. So that's quite a lot of information to swallow in that last sentence. So I'm going to break this down now into each of the elements and give you a little bit more detail. So the interaction between the nodes of the knowledge graph is fundamental to producing an in-depth analysis. Today, a lot of this information is collected in spreadsheets and in various forms and is very labor intensive and cumbersome to collect. And it's not very easy or visual to understand. In our case, we use a knowledge graph which looks at circularity across data silos and automatically identifies carbon pathways, which allow you to easily identify carbon hotspots of guilty parties. So this knowledge graph has all of the interrelationships between products, materials, supplies, and energy sources all the way across the value chain. And all the relationships between nodes are shown in the knowledge graph, including dependencies. So within the knowledge graph, you can see things like the composite item or the GRFP panel, for example, that we're looking at as an alternative design option. You can see the subcomponents of that, like fiberglass, other material like catalysts or UP resin that goes into the fiberglass panel, the relationship to material suppliers and supply chain component manufacturing processes, transport, delivery, all the way to end use. And we can model this all the way down to the molecular level of the material used. So we have a very, very detailed understanding of the carbon pathways. More importantly, alternative materials that can reduce carbon impact and environmental impact, as well as processes, can be introduced and visualized easily in the knowledge graph. So you might identify carbon pathways and hotspots that are generating, that are significant contributors to carbon impact, and you can start to look at alternative materials and processes to lower the carbon impact and remove those hotspots, all in a very visual user interface. Added to this, the knowledge graph has embedded analytics, which provide evidence-based metrics. These are integrated into each node of the knowledge graph. So you can look at a panel or a specific material that's being used in the design, and you can see the exact environmental impact of that material, its manufacturing process, or supply chain against those 13 environmental metrics mentioned earlier. And all of that information is summarized and aggregated into this environmental cost indicator that was mentioned before. So the use of the knowledge graph and the embedded analytics and the environmental metrics kind of give you a view of where you are today on your project. You can think of it sort of as a carbon balance sheet, or almost like a Polaroid snapshot in time of where you are at a particular moment in time. But we also want to look at the future, and we want to run scenarios that can consider what happens if we do things differently. So we have a capability that we call Net Zero Optimizer with advanced AI that allows you to build a series of strategies to reduce carbon or any of those environmental metrics like toxicity or environmental cost. You can optimize on those metrics across the entire design, or you can also drill down into the details of the knowledge graph and optimize across different environmental metrics at different areas of the knowledge graph to come up with the optimal profile. So what the Net Zero Optimizer does, it allows you to look at the impact of all the variables, and it recommends the optimal path to take to reduce the carbon impact according to the strategies that have been set. This capability can be applied across the various scopes, scope 1, 2, and 3, and across the various stages of your life cycle. This is a key capability of the RD Sustain platform. We've seen, as Nick mentioned, at the design stage, that we can deliver anywhere from 35 to 60% carbon emissions reduction through the use of the Net Zero Optimizer and incorporating scenario analysis into the design. You can go to the next slide, Derek, please. So here I want to talk a little bit around what's underneath that solution. Nick spoke earlier around this concept of a data mesh supported by a data fabric. What a data mesh does is it provides contextual, business-driven, API-enabled data products. The data fabric allows the continuous feeding of the data product. So just like software, a data product has releases, version control, and QA checks built in. This allows the pendulum of control to shift from IT to the business, where the IT department provides the platform and the security and the tooling, and then business owners become responsible and accountable for the data and the outcome that it provides. So rather than working with a bunch of disparate spreadsheets without version control and trying to manipulate all that information in spreadsheets and other forms without a visual palette like a knowledge graph to see all of the relationships, we provide basically a paradigm shift from data silos to decentralized ownership with data products supported by IT, centralized IT infrastructure. As shown in the graphic in the middle, what RD does is bring all of this data together from various providers into a centralized sustainability lake. So there's different kind of providers. We've got external data that are in relational formats, structured formats like Ecovent, for example, and unstructured data sources from various chemical databases. We've got internal data specific to the client or specific to the partners like the architects or the design agencies in formats such as CAD drawings, bill of materials, building information systems, etc. And then we've got regulations, standards, and guidelines that are applicable to the industry that need to be adhered to. For example, how do you ensure that the analysis is not only related to sustainability, but it also addresses compliance around fire safety, for example, which may be relevant in a certain situation? Are you modeling something as an alternative material that is not compliant with mandated norms? So we need to ensure that the recommendations we make are all compliant with all the regulations and standards. So all this data is brought in, it's aggregated, it's harmonized, it's standardized, and that information is presented to the application for visualization in the knowledge graph and the analytics dashboards mentioned earlier. Using an architecture like this and an approach like this, this allows you now to deliver multiple use cases, not just a single use case or a subset. There's multiple consumers of the data, and because there's multiple lenses through which decisions need to be made, these multiple lenses are considered in the design of the data product for the various consumers, like designers, architects, data scientists, analytics teams, compliance, etc. Move on to the next slide, please. So we will now deliver a short demo on video that's specific to the tunnel design for the mega construction project introduced earlier, and show how Sustain 360 has been applied from a knowledge graph, analytics, and net zero optimization perspective. So Derek's now going to play a short video that was developed by Mohammed, our colleague who's online here. And following that, we will have a Q&A and we can discuss various aspects. Thank you. Derek, I'm not.
Bring in the power of visualization, quick modeling, and alternatives tracking for the decarbonization journey. Let's see the different features of it now. This is the current login page where we need to bring in or where we need to put our credentials to have the access for the LCA 360 platform. Once we press the login, the LCA 360 software takes us to the projects page, which is meant for arranging and segregating for ease of classification and folder documentation. Under each project, there can be a minimum of one LCA, or there can be a multiple LCAs depending on the business need within the projects. Each of these LCAs might have different use cases, might be built on different boundaries. It can be from cradle to gate, gate to gate, cradle to grave, etc., depending on the business needs. As we all know, the flexibility which is provided by LCA for modeling by ISO 14040. Once we go inside any of the visuals, so these all are different LCAs, and once we go inside any of the LCA model, we can see the products or the system which is within the scope of the project or within the scope of the current product system. So the current canvas shows us an infrastructure project with 4 different design options. And in this, the client wanted to see the design option with minimum environmental impact. The dashboard on the right serves the purpose immediately for the client to see which design option has the minimum or which design option has the minimum environmental impact, and also to see what are the different environmental impacts. We do have multiple environmental impact categories, maybe starting with global warming potential, to acidification potential, to the eutrophication potential, ozone depletion potential, etc. So maybe if we select global warming potential, which is the carbon footprint, the impacts are segregated between scope 1, scope 2, and scope 3. I double click just on the one model. We also can see here the product systems are also segregated between scope 1, scope 2, and scope 3 as well. And just see what is within the scope 2 or scope 1. So if I double click on scope 2 again, you can see what are the different systems available within each of the system. That's basically the showcasing, like, okay, you do have multiple impacts classified, but what are those impacts or where are those coming from? So that is basically understood from the details of the mission. But to understand on a high level, we can see it here on the dashboard. What are the comparisons? Along with global warming potential or the carbon footprint, we also do have 13 other environmental impacts, as well as ECI cost or environmental cost indicator, basically, which is not available in any of the software. So this is a normalized environmental impact parameter, considering all the 13 environmental impacts as per the CML impact category. In the bottom, we do have the charts to visually see and understand which are the items which is contributing more in the system. Coming outside of the dashboard, on the top of the screen, LCA 360 provides tools such as graph tools, which is used for selection, which is used for the expansion of the system within the canvas. So I click here and collapse, it gets collapsed, and we click here and explore, it gets. So these are the graph tools in terms of selection and modification within the graph of visualization. Selection tools are used for building the graph or developing the relationship between the nodes. The layout tools basically provides the ease of layout. Maybe different types of layouts can be developed, tree layout, hierarchical layout, etc. The relationships helps in understanding which are the relationships available between the different nodes or between the selected nodes. The search feature on the top supports in building or bringing in the items to the canvas, as well as identifying what are the different nodes built in or present within the canvas. That's the help of first. On the top, we can see more or less the modeling tools. On the right, the dashboard in a first look. We also do have advanced features such as compare options, which quickly compares between the different options and showcases like what are the different items which is impacting more or which is comparably impacting less within when compared between two different options. So, and that as well, it can be compared based on different environmental parameters. So if we select here abiotic depletion potential and we do want to compare between one option and another option, we can do see here the difference coming in where the difference or where the basically the system is having a difference in facts. Optimized alternatives is a powerful tool or powerful feature within LCA 360 where it supports in identifying or minimizing the environmental impacts and hence supporting in the decarbonization journey. So on the top, we do have the strategies. Directly, we can select the minimized global warming potential and we can see what is the minimized global warming potential pathway within the system. Or on the decision points, maybe certain cases, there might be chances like for particular sections or particular groups, we need to minimize the human toxicity potential. Maybe for certain items, we need to minimize global warming potential. So such kind of customized strategic decarbonization alternatives can be selected in the strategy part. And once it is selected and saved, the items are highlighted on the screen to showcase like what are the alternatives which can be seen for the decarbonization pathway. So that is a quick walkthrough of the different features within the LCA 360 knowledge graph. We also do have the power of supply chain visualization, wherein supplier locations, the transportation modes, and the recipient locations are stored, and that can be further modified for modeling. And real-time map integrations are also available. A quick walkthrough of the platform with the tools on the top, the dashboards and the chart visualization on the bottom, and the canvas on the in the center. One another feature which I just wanted to highlight is the timeline feature, which is basically integrated on project-to-project basis, where we can see what is the current status of a product and what will be the product looking like maybe in a 2025 period, like, or in a 10 years period, or in a 5 years period, or in a 3 years period. So basically, it supports in setting out SBTi targets or climate neutral targets for a product development. So this is a quick demo of the tool. Thank you.
Okay. I had to stop share to get out of that, and now I'm going to hop back into the presentation. So bear with me a moment whilst I share screen again. Here we go. All right, so I think we're handing back now to Nick.
Hey, Nick, you should unmute.
Great. Thank you very much, Derek. So just a reminder for the audience, before we cover some of the outcomes and impacts, that this project called The Line was a mega project inside of a giga project. So there's actually multiple mega projects inside of this giga project called NEOM. We were only doing a specific engagement in partnership with the project itself and some of the other collaboration companies as part of this for only one portion. So as you can see, that this is based only on this project on a 2-kilometer stretch of the tunnel. It wasn't on the full 100-kilometer length. The numbers represent the metric tons of CO2 equivalent. So just for 2 kilometers of the tunnel, if they continue down the path of using concrete, which was the original was the baseline option before we rebaselined, they would generate 706 million metric tons of carbon. This is a massive number. It's actually the equivalent of 317,000 family cars driving 15,000 kilometers per year. But the modeling out of the alternatives and looking at it from design phase to see how carbon footprint could be reduced using the knowledge graphs, embedded AI in the data fabric, we could see that by using less concrete and a variety of different materials and different transportation methods, that really started to dig deeper into the supply chain and the modeling or the greening of that supply chain, we essentially reduced the carbon impact by about 30%. So if the company selected option 1A as its solution preference, we would have reduced the carbon impact by equivalent of 94,000 cars, which would have come off the road per annum. And option C represents about 108,000 cars per annum. The breakdown on the right-hand side of the slide shows that the material stage, that's really where the most significant impact is, as well as the maintenance stage, because material recycling is much more improved with the alternative to concrete. So let's have a look at what we've learned from the project, key takeaways, and also recognize that, as I mentioned earlier, construction is one of the third largest contributors of emissions because of the energy intensity in steel and glass and materials and concrete. But this does apply to original equipment manufacturers, consumer packaged goods, anywhere where you have a product base and materials being used. It does apply directly, and we are working across multiple industries now. But firstly, it's really about collaboration with your stakeholders. You can say customers, but really, you have a need and an intent and want to understand your why in decarbonization, no matter what sector you're in, no matter what role you have as a leader in a company. And, it's across the globe. And you're trying to work in an easy, simple, transparent method, and transparency being key here, and understanding the value from that data. And how do we create together evidence-based CO2 emission calculations? What you've seen in the demo, the details Bill talked about as their Chief Product Officer, really come to life in the Sustain 360 platform. Secondly, you need to find a platform and have a data platform and a strategy that brings together, hundreds of data sources, which we've managed to do quite elegantly and powerfully, dealing with multiple formats and standardizations. And it's so much more than being able to drop things in a data lake, have different use cases with different data scientists to model. You can't do it to scale without the architecture that we built in using the data mesh and the powerful knowledge graph. More importantly, the collaboration and the ability to model the alternatives, rethinking what you may have as your baseline to say this is the best. Be open and think out of the box to rethinking that, especially from a carbon footprint point of view and the impact on our world. It's in the environment. It's just critical. It's something that we all have to do. And finally, the 360 Knowledge Graph software provides the evidence-based reporting, and that opens a Pandora's box for some, but it's coming fast. And it's a commitment you make as a company, as a good steward of the company, as governance applies, as you're public in your reporting. It's having that evidence-based reporting to show that you've achieved what you actually set out to do in terms of reducing your carbon footprint. So with that concludes our portion. We can open up the polling, and again, thank you all for attending our session and CDOIQ for the opportunity. Derek, I'll hand it back over to you.
Great. Thanks, Nick and Bill and Mohammed. I think now, just before we jump into the Q&A, and I've seen there are a couple of questions coming up here, and that's great. But let's just have a look at the polls. So I see that our audience has been responding, so that is good. Let me just locate them here. All right, so the first question was, how important is sustainability to your organization's mission and goals? And it's coming out as very important. There are 21 responses saying very important. And there are 4 responses saying somewhat important and 3 saying not important. So, it's pretty conclusively, very important is the answer to that one. The second poll was, how mature is your organization's sustainability reporting? And there, we've got 5 that are very mature, but we've got 13 that are somewhat mature and 7 that are immature. All right, so it's kind of middle ground wins in this one in terms of somewhat mature. And there's a fair amount of folks that are in the immature, with a very small amount that are very mature. And then last but not least, we're talking here about the data platform. So we're saying, how mature is your organization's sustainability data platform? And here we have 5 very mature, 13 under consideration, or just in the design phase, and 6 none. Thinking about it perhaps, but really haven't gotten into the design yet. So again, it's kind of in the middle there. It seems like a bunch of folks are designing and considering this, and very few are in the mature phase. So that's the feedback from the poll. The polls remain open after this, so feel free to continue to put your thoughts into it, I'm sure everyone's gonna benefit from seeing the results of these polls later on too. All right, that said, let's jump into the Q&A. So the Q&A session, there are a bunch of questions already out here. Just find them. Here we go. All right, so the first one is, how can organizations leverage machine learning and AI techniques to enhance the functionality and value proposition of data products? I'm not sure who would like to pick that one up, but
Bill, you want to take that?
Yeah, I can speak a little bit to it, and Mo, maybe you can add to what I'm going to say in terms of some of the AI that's embedded in our approach. But I think in this type of solution, we have a number of touch points around AI. We use natural language processing to ingest unstructured data and get all of that data harmonized. So there's an AI component around constructing the data lake. We have AI used in sort of the automatic creation of the knowledge graph and the link prediction and the generation of the nodes and relationships within the knowledge graph. We use AI around how we approach selecting similar and alternative materials in your design to inform the knowledge graph on how to look at different types of considerations. We use a large language model, OpenAI, with a GPT engine to identify those material and chemical alternatives. So that large language model is trained on a whole bunch of different sources in terms of the different regulations, reporting requirements, global standards in order to come up with compliant recommendations around alternatives. Let me think from the top of my head. Maybe Mo, you can add to that conversation and maybe chime in with some additional details.
Yeah, sure. Thanks, Bill, for giving an overview on how the Sustain 360 has utilized AI and machine language in the development and also in ensuring that the sustainability data are identified, are properly processed, and taken for the final reporting or final assessment. Mostly in the organizations, the AI and machine language or MLs can be utilized to ensure that the different things are read automatically. The multiple manual interventions are eliminated, and particularly in terms of the sustainability assessments or the ESG reporting part, the reportings are done accurately without much errors, or there are very minimal manual interventions. So whenever an organization is in its onboarding phase, there might be multiple interventions or checkpoints need to be incorporated while integrating the AI and ML models. But once the model is trained trained well for the exact operations, different kind of data points, maybe the bill of material, the supplier data sheets, which organizations are plugging in, the model, the tools will be able to read out and eliminate and pinpoint or select key data points, maybe in terms of the quantity, the supplier locations, which can ease the assessments, particularly in the sustainability, maybe the supply chain assessment, the carbon assessments, etc.
Great. Okay, Derek?
Yes. Nick. Sorry.
Other questions?
Oh, okay. Sorry. I thought you had a question. Okay.
Yeah. Are there more questions?
Yes. So another question, I guess, looking at that timeline, you had the various phases of this. You have the opportunity to kind of model the different alternative ways of reducing, the impact, environmental impact, etc. Whereabouts are you in the overall thing? Because obviously this is a long-term project. It's a mega project. It's how many years runway are we still looking in terms of the completion of this? I'm not sure that I fully had an understanding of that.
Yeah. So for the person who asked that question, it is an unbelievable project, and what's been quite protected geography on the Red Sea. You have a lot of natural things there, ecosystem that's quite sensitive. So it's not just the Kingdom of Saudi Arabia setting forward a 2030 or 2050 goal, but it's literally just massive. And if you're just curious about the scale and size of the projects, I encourage you just to go to neom.com. This project for these tunnels, is multiple years, but it is the infrastructure, the backbone to move things and move materials and move people underground. There's still a sea component to materials coming to the construction site. And this is just for the line project, which is a city, self-sustained city. There's Octagon, which is a high-tech living and kind of futuristic development within the city. There's a ski resort called Trojana, which is also part of the NEOM project. So there's these mega projects within. We obviously have started on tunnels within the portion of the line. It's our now collective goal in working with our partners in the Kingdom of Saudi Arabia and supporting regions in the Middle East who are contributing to continue on. So I can't give you a specific date, but it's years of work for certain. So there's no lack of opportunity in continuing to decarbonize or make sure there's zero footprint.
Right, and I think sort of a rider on that question is, given that it's multi-year, and given that you've done all this really great work up front, what's going to be really interesting will be to monitor the effect of some of those choices going forward and actually comparing, some of the projections as you move forward in the project life cycle. So, maybe just some thoughts about that in terms of the platform that you've put in place, and some of the thoughts around, how you're aiming to accomplish that.
Sure. Bill, do you want to take that one around the life cycle from design to operate and maintain?
I think, Mo, you kind of showed at the end of the demo sort of the timeline feature. And I kind of talked about in my presentation how in design we can produce a snapshot of what things look like and try to optimize it. And then the platform allows you to kind of forecast that forward. Maybe you can speak a little bit more around that feature.
Yeah, thanks. So basically in terms of the operationalization, so currently maybe in the assessments or in the project assessments, what we have seen in the demo, we have done the design assessment. We are also trying to incorporate the operationalization feature where we are trying to plug in the real-time impacts while the construction is going to pull in into the actual field. So with the hardcore sensors, the technology in place, we will be able to sense what is the actual emissions, what is the load carrying, what is the load taken maybe in terms of the excavation, what is the material that's being transported to the site. So we are also trying to operationalize the LCA. So that's also one of the key tagline which Ardi is putting forward, to understand, like, not only assess the design phase, but also operationalize and monitor the LCA throughout the project. So that's one thing. And maybe particularly in terms of the timeline feature which we are having. So the timeline feature does do two functionality. One is prediction or like strategic decision making. Like so we are having a baseline scenario of 2019, the organization, how it operates currently. And the organization want to go for a 50% reduction of GHG by 2025. So the organization has kept some strategic points, maybe the renewable energy purchase agreements, some low carbon alternative materials that the organization is planning to purchase. There might be some machinery that's getting exchanged. So such kind of informations are also plugged into our software, so that like once we pull out or change the timeline, the difference can be visualized within the software. So two approach for the data. One is through the artificial intelligence to bring in like what can be the projected technology in the upcoming year. That's one approach. And the second way, by manually inputting the strategy of an organization.
Mm-hmm. Okay.
And maybe I'll add to that. Well, another really exciting thing that we're working on is, okay, Mo just explained how you can use the software, and it's really something that, you know, different types of users and stakeholders who are the data owners now can use to run scenarios, save their cases, forecast the future. We're also building a capability to layer on top of this climate risk. So we can look at the baseline scenarios, and then we can start to look at, based on the geographic location and leveraging different kind of client risk models to predict weather and different climate impacts, we can simulate climate risk on top of this, and really in one platform do what it normally takes today, two or three different software products to address, you know, ESG, net zero optimization, and climate risk all in one environment. So that's an exciting development that we're working on now as we go into 2024.
Nice. Yeah. If you can do it all in one place, what a pleasure. All right. Well, you know, we are almost at the end here. We're in 59 minutes, 1 minute to go. So good timing. This has been a really fascinating discussion. Thank you so much for sharing, you know, some real practical insights into how to do this. You know, just a big thank you to all three of you, Nick and Mohammed and Bill, for joining us today and providing that insight, and all the best with the rest of your endeavor out there.
Thank you.
Thank you very much, Derek.
Thank
Thank you everyone for attending, and let's keep the planet moving forward in green. It's all of our responsibilities. Thank you, everyone.
Thanks, everyone.
Thank you, everyone.